If two rows or two columns are interchanged, the value of a determinant changes in its sign. So positive value converts to negative or negative value converts to positive value. The value of a determinant is equal to 0 whenever its two rows and two columns are same. If two rows and two columns are identical, then the value of a determinant is equal to 0. If any row or a column of a determinant contains sum of two elements, then the whole determinant can be expressed as sum of two individual determinants. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now today in this session I am going to discuss very important concept, that is the properties of determinants and the problems based on this. Definitely you will get one definite 4 marks question from this concept, right? Now let us come to the properties first. Let me explain the properties and the proofs, then I will take few examples, then I will go for the problems based on the properties. Now let us discuss the first one. What is the first property? The property number 1 states that the value of the determinant, the value of a determinant remains unchanged. The value of a determinant remains unchanged if its rows and columns are interchanged. If the columns or rows are interchanged, then the value of a determinant will remain the same. The value of a determinant is not altered when its rows and columns are interchanged. If a transpose, the value of the determinant will remain the same. So let us consider an example. Now let us prove this. I will consider an example. Delta is equal to A1, A2, A3, B1, B2, B3 and C1, C2, C3. Now interchanging, what is to prove? The value of the determinant remains unchanged if its rows and columns are interchanged. Let us interchange the rows. Now interchanging the rows, changing the rows to columns. Let me interchange the rows to column. Then we will get delta dash is equal to, so first row become first column A1, A2, A3. Then second row B1, B2, B3 will become second column. Third row C1, C2, C3 will become third column. Now delta is first and interchanging the rows to column, this will become delta 2. Now what is to prove that? To prove that delta dash is also equal to delta. The value of determinant delta dash and delta are same. That means the value will remain the same whenever the rows and columns are interchanged. Now let me expand this. Now delta is equal to, expand this. This is plus, minus and plus. A1 into, if you multiply B2 C3 minus C2 B3 minus A2 into, this row and column is deleted, B1 C3 minus C1 B3 plus A3 into, this row and column is deleted, B1 C2 minus C1 B2. Now simplify this. So this is equal to A1 B2 C3 A2 3. Let us take 1 2 3 minus A1 C2 B3 A1 C2 B3. Next minus A2 B1 C3. So this can, let me take B1 A2 C3. Minus into minus plus A2 C1 B3. Let us consider 1 first. C1 A2 B3 plus, now multiply this. A3 B1 C2 can be as B1 C2 A3 minus A3 B1 C2, that is C1 B2 and A3. Let us represent this as equation number 1. So the first one is expand delta. Delta is equal to A1 A2 A3 B1 B2 B3 C1 C2 C3. What we will get, this is the equation we will get for delta. The value of delta is this. Now let us go to the second one. Now expand this. Delta dash is equal to, now delta dash is equal to, what is delta dash? A1 A2 A3 A1 A2 A3 B1 B2 B3 C1 C2 C3. Now expand this. According to definition, the value of delta dash is also equal to delta. Now expand this. This is plus, minus and plus. Now A1 into B2 C3 minus B3 C2 minus B1 into, this row and column is deleted, A2 C3 minus A3 C2 plus C1 into, this row and column is deleted, A2 B3 minus A3 B2. Simplify this. Now this can be done as, let us consider 1, 2, 3, A1 B2 C3 minus A1 C2 B3 minus B1 A2 C3 minus into minus plus B1 A3 C2 can be done as B1 C2 A3 plus C1 A2 B3 minus C1 B2 A3. This is equation number 2. Now observe equation 1 and 2. See A1 B2 C3 plus A1 B2 C3 plus minus A2 C2 A1 C2 B3 A1 C2 B3. Same we have. So therefore from 1 and 2 we can say that delta dash is equal to delta. That means the value of a determinant remains same. The value of a determinant is unaltered, unchanged whenever its rows and columns are interchanged. That's it. This is how we are going to verify the property. Okay. Now let us consider an example. For example, if A is equal to, a square matrix A is equal to 2 minus 3 5 6 0 4 and 1 5 minus 7 1 5 minus 7. Now let us verify. So first find out the value of determinant of A. Determinant of A is equal to 2 minus 3 5 6 0 4 1 5 minus 7. Let us expand, plus minus and plus. So this is equal to 2 into 0 minus 5 4s are 20 minus into minus plus 3 into, this row and column is gone, 7 6 are 42 minus 4 plus 5 into, this row and column is deleted, 6 5s are 30 minus 0. So this is equal to 2 into minus 20 plus 3 into minus 46 plus 5 into 30. Now this is equal to minus 40 minus 46 3s are 138 plus 5 3s are 15. This is 150. So this is equal to 150 minus 178. 178. So this is equal to minus 28. The value of determinant A is equal to minus 28. Okay. Now according to the definition, if the rows and columns are interchanged. Now let us interchange. Interchanging the rows. Interchanging rows to column. Now this can be written as A dash. A dash is equal to the determinant 2 minus 3 5 then 6 0 4 1 5 minus 7. According to the definition, what is the answer we have to get? This is also equal to minus 29. Let us check this. Plus, minus and plus. 2 into 0, 5 4s are 20, minus 6 into, this is gone, 7 3s are minus into minus plus, 21, minus 5 5s are 25, plus 1 into, this is gone, 3 4s are 12, minus 0. So this is 2 into minus 20, minus 6 into 21 minus 5, 25 is minus 4, plus 1 into minus 12. So this is minus 40, minus into minus plus 24 minus 12. So this is equal to 24 plus minus 42, 52. So 24 minus 52 is minus 28. That's it, minus 28. So therefore the value of determinant A dash is also equal to minus 28. So this is how we are going to verify the property. So in the examination, they may ask, verify or prove that the value of a determinant remains unchanged unaltered whenever its rows and columns are interchanged, or they may give a problem like this. For this matrix of order 3 rows and 3 columns, verify that the value of a determinant remains same whenever its rows and columns are interchanged. Just find out the value of A and take the transpose and find out the value of this. A and A dash are found to be same. We can say that therefore the value of determinant A is also equal to the value of determinant A dash. That's it. Very important concept. Now let us come to the next property. Property number 2. If two rows or two columns of a determinant are interchanged, then the sign of a determinant changes in sign. If two rows or two columns are interchanged, the value of a determinant changes in its sign. So positive value converts to negative or negative value converts to positive value. Let me see. Now let us verify. Let us take an example. Now let us come to the proof. Let us consider delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. Expand this with respect to first row. Plus, minus and plus. Now what is to prove? Let us take interchanging first and second rows. Now let us interchange the first and second row. Then we are going to get delta dash. Consider it as delta dash. Now interchanging the first and second row. So first row is A1, A2, A3. This is row 1. This is row 2. Interchanging row 1 and row 2. R1 and R2 interchange. So R1 becomes R2, R2 becomes R1. Now I will write this as B1, B2, B3 and A1, A2, A3. This is C1, C2, C3 as it is. Just interchanging row 1 and row 2. B1, B2, B3 becomes first row and A1, A2, A3 becomes second row. According to the definition, the answer we are going to get is to prove that delta dash is equal to minus delta or delta is equal to minus delta dash. The value of a determinant is minus negative. Let me check. First expand this. This is equal to A1 into B2 C3 minus C2 B3 minus A2 into this row and column is deleted B1 C3 minus C1 B3 plus A3 into this row and column is deleted B1 C2 minus C1 B2. Now this is equal to multiply it. Now I can take A, B, C. Now this is A1 B2 C3 minus A1 B3 C2 minus A2 B1 C3 minus into minus plus A2 C1 B3 can written as A2 B3 C1 again plus A3 B1 C2 plus into minus A3 C1 B2 can written as A3 B2 C1. Let us consider this as equation number 1. So A3 B2 C1. This is expanding the general first delta. Now let us come to the second part. What is the second part? Interchanging first and second row. I will come to the second part. Delta dash is equal to into B1 B2 B3 B3 A1 A2 A3 C1 C2 C3. Expand this. Plus, minus and plus. So let us expand this. Plus, minus and plus. This is B1 into A2 C3 minus C2 A3 minus B2 into this row and column is deleted A1 C3 minus C1 A3 plus B3 into this row and column is deleted A1 C2 minus C1 A2. Now simplify this. Now let us consider ABC as the order. B1 A2 C3 can written as A2 B1 C3 minus B1 C2 A3 can written as A3 B1 C2 minus B2 A1 C3 can written as A1 B2 C3 minus into minus plus B2 C1 A3 can be written as A3 B2 C1. Okay. Plus B3 A1 C1 can be written as A1 B3 C2 minus B3 C1 A2 can be written as A2 B3 C1. This is equation number 2. Now just watch, just observe carefully equation 1 and 2. From 1 and 2, see in equation number 2 we have A2 B1 C3 plus A2 B1 C3. Here we have A2 B1 C3 negative. This is minus, here we have positive. Okay, again A3 B1 C2 minus A3 B1 C2. See here A3 B1 C2, this is positive, here we have negative value. Okay, so therefore from 1 and 2 we can say that delta dash is equal to minus delta, or delta is equal to minus delta dash. That means the value of a determinant changes in its sign whenever its 2 rows and 2 columns are interchanged. Now let us take an example. For example, so for determinant A in the previous problem, let us consider the previous example. What is the answer we got? Determinant of A is equal to minus 28 for A. Now let us interchanging. A dash is equal to interchanging R1 and R2. R1 and R2. Let us represent delta dash or delta 1 as R1 and R2, interchanging R1 and R2. Now I will change this. So 604 and 2 minus 3 5, 2 minus 3 5, and the third row will remain the same, 1 5 minus 7, 1 5 minus 7. So according to the definition, I have interchanged 2 rows. What is the answer we are going to get is plus 28. Let us check this. Plus, minus and plus. 6 into minus into minus plus, 7 3s are 21, 5 5s are 25, minus 0 into number is 0, plus 4 into 5 2s are 10, minus into minus plus 3. So this is equal to 6 into minus 4 plus 4 into 13. Okay. So 6 4s are 24, minus 24 plus 13 into 4, 13 4s are 52. So what is equal to? Minus 24 plus 52, that's equal to plus 28. This is the answer. That means the value of interchange delta 1 is equal to plus 28. Delta 1 or A1. So if you interchange 2 rows and 2 columns, the value of a determinant changes in its sign. That's it. Okay. Now let us come to the property number 3. Now what is property 3? If 2 rows or columns of a determinant are identical, same, then the value of a determinant is 0. Very simple. If 2 rows and 2 columns are same, then the value of a determinant is equal to 0. Now let us consider this itself. Let delta is equal to A1, A2, A3, B1, B2, B3, again B1, B2, B3. So according to the definition, the value of this determinant is equal to 0 because these 2 rows are same. Because since 2 rows are same, identical, that is row 2 and row 3 are same. So according to the definition, the value of determinant is equal to 0. Let me check whether we will get it or not. Now this is equal to plus, minus and plus. A1 into B2 B3 minus B2 B3 minus A2 into this row and column is gone, B1 C3 B1 B3 minus B1 B3 plus A3 into this row and column is deleted, B1 B2 minus B1 B2. What you will get? This is equal to A1 into B2 B3, this is 0, A2 into B1 B3, B1 B3 0, plus A3 into these two gets cancelled, 0. So this is 0 minus 0 plus 0 is equal to 0. So therefore the value of determinant is 0. That means the value of a determinant is equal to 0 whenever its 2 rows and 2 columns are same. If 2 rows and 2 columns are identical, then the value of a determinant is equal to 0. Let me take an example. For example, Let us consider 1, 2, 1, 3, 2, minus 1, again 1, 2, 1. According to the definition, the value of this determinant is equal to 0 because there are two columns, same, two columns are same, identical, that is C1 and C3. Column 1 and column 3 are same. Let me check this. Plus, minus and plus. 1 into 2 ones are 2, minus into minus plus 2, minus 3 into this is gone. 1 2s are 2, minus 1 2s are 2, plus 1 into 1 2s are 2, minus 2, minus 2. So this is 1 into 4, minus 3 into 0, plus 1 into minus 4. So 4 ones are 4, minus 0, minus 4, plus 4 minus 4 gets cancelled. This is equal to 0. So if two columns are same, then the value of a determinant are 0. Let me take one more example. If B is equal to 1, 3, 5, 6, 7, 1, again 1, 3, 5. Then according to the definition, the value of determinant is equal to 0 because these two rows, that is R1 and R3 are same. So therefore, the value of determinant B is equal to 0 straight away we can put. That's it. Right. Hope you followed. Okay. So these type of problems are very, very important. You may expect one property and a problem based on these properties. Right. Now let us come to the next property. Property number 4. If all the elements above or below the principal diagonal are zeros, this is very important. We are using this property to solve the problems based on the properties of determinants. If all the elements above or below the principal diagonal are zeros, then the value of a determinant is equal to the product of the principal diagonal elements. So here all the elements above or below the principal diagonal are zeros. Now let us consider, let delta is equal to, come to the proof, let delta is equal to A1, A2, A3, 0, B2, B3, 0, 0, C3. So here all the elements below the principal diagonal are zeros. According to the property, if all the elements below the principal diagonal or above the principal diagonal are zeros, the value of determinant is equal to, just multiply A1, B2, C3. A1 into B2 into C3. That's all, the value of determinant. Now let us expand and check. Now let us expand, plus, minus and plus. A1 into B2 C3 minus 0 into any number is 0, minus A2 into this row and column is deleted, 0 into C3, 0 into B3, 0 minus 0, plus A3 into this row and column is deleted, 0 minus 0. What you will get? This is A1 into B2 C3 minus 0 minus 0. That's equal to A1, B2 and C3. A1, B2 and C3. So if all the elements above or below the principal diagonal are 0, then it is equal to, the value of determinant is equal to product of the principal diagonal elements. Now let us take an example. Let me take an example. For example, consider this 1, 2, 3, 0, 4, 2, 0, 0, 3. Then see here, all the elements below the principal diagonal are 0. The value of the determinant is equal to 1 into 4 into 3. This is nothing but 12. If you want, you can expand it and check. Suppose one more example. If A, determinant of A is equal to, see if it is like this, 3, 0, 0, 2, 4, 0, 1, 2 and minus 1. What we will get? So since all the elements above the principal diagonal are 0, therefore this is equal to 3 into 4 into minus 1, this is equal to minus 2. That's it. So if all the elements below the principal diagonal or all the elements above the principal diagonal are 0, then the value of a determinant is equal to product of the principal diagonal elements. That is upper triangular and lower triangular matrices. Right. Now let us come to the next property. What is the next property? If all the elements in a row or column are zeros, this is also very important. If all the elements in a row or column are zeros, then the value of a determinant itself is 0. If all the elements in any row or column are zeros, then the value of a determinant is also equal to 0. Now, let us verify that. Proof. Now let us come to this. Let delta is equal to A1, A2, A3, B1, B2, B3, 0, 0, 0. So, according to the definition, the value of this determinant is equal to 0. The reason is because all the elements in third row, in row 3, all the elements in row 3 are zeros. If all the elements in one row or one column are zeros, then the value of a determinant is equal to 0. Now let us verify this. Plus, minus and plus. A1 into B2 minus B2 into 0 is 0 minus 0 minus A2 into this is gone, 0 minus 0 is 0 plus A3 into 0 minus 0 is 0. So totally you will get it as 0. Okay. If all the elements in a row or column are zeros, then the value of a determinant is 0. Very important property. Now let us take an example. 3, 2, 4, 1, 2, 5, 0, 0, 0. Then the value of this determinant is 0 because all the elements in third row are 0. Third row are zeros. Another example, let us take one more example. The value of determinant is equal to 2, 4, 5, 0, 0, 0, 1, 2, 3. So this is also equal to 0 because all the elements in second column are 0, right? Suppose if it is like this, 3, 4, 5, 6, 7, 1, 0, 0, 1, then this is also equal to 0. So this property is very useful for solving the problems based on the properties of determinants. Okay. Now let us come to few problems. Based on this, let us take few problems. These problems are very, very important. Let us discuss few problems based on these properties. These are all very important problems for so maybe you will expect this type of problem in part E, B question, 4 marks. This is for 4 marks. Now let us consider the first problem. Show that determinant A, B, C, A plus 2x, B plus 2y, C plus 2z, x, y, z is equal to 0. Now there is one property in determinants. If any row or column contains the sum of two elements, if any row or a column of a determinant contains sum of two elements, then the whole determinant can be expressed as sum of two individual determinants. So here if you observe carefully, let us take LHS. What is LHS? A plus 2x, x, B plus 2y, y, C plus 2z and z. So if you observe carefully, here this can be written as, this contains sum of two elements, A plus 2x, B plus 2y, C plus 2z. So we can split like this, A, B, C, and the value of third determinant x, y, z as it is, plus again A, B, C, the value of x, y, z as it is. Here second row contains sum of two elements. So take all first elements A, B and C for the first determinant and all the second elements for the second determinant, 2x, 2y, 2z. That's it. Okay. Now here just keep this as it is, A, B, C, x, y, z, plus I can take two common factor. You can take two common factor. This is A, B, C, x, y, z, again x, y, z. Now if you observe carefully, according to the property, if two rows or two columns are same, see here ABC, two rows are same, XYZ are same. If two rows, two columns are same, then the value of a determinant is equal to 0. So therefore this is equal to, first answer is 0 plus 2 into second answer is also 0 because two rows are same. Two rows are same, identical. See here, ABC, two rows are same, therefore it is 0. Here XY, second column and third column are 0 are same, therefore this is 0. 0 plus 2 into 0 is 0. This is equal to 0, the required RHS. That's it. So, just convert the given problem into the simplest forms and apply the properties. That's it. Okay. See here, we have taken 2x, 2y, 2z for the second determinant and a, b, c for the first determinant. So, any row or column contains the sum of two elements, then the whole determinant can be expressed as sum of two individual determinants. So, here a, b, c, x, y, z. Next, a, b, c, 2x, 2y, 2z, x, y, z. So, two common factor, these two are same, these two are same, therefore 0 plus 0 is equal to 0. That's it. Okay. Hope you followed this. Now, let us come to the next problem. What is the problem? Prove that x plus y, y plus z, z plus x, z, x, y, 1, 1, 1 is equal to 0. Let me check what is the answer we are going to get. Now, to prove that the answer we are going to get it as 0 or not. Now, let us take the given equation. Given equation is x plus y, y plus z, z plus x, then z, x, y, 1, 1, 1. Now, let us take, see, keep it in mind, this is R1, R2 and R3. Now, taking R1 dash is equal to R1 plus R2. R1 plus R2. That means add these two, R1 and R2. What we are going to get? This is equal to, so we are changing R1 dash, second and third are same, Z, X and Y as it is, 1, 1, 1 as it is. We are adding this, see here, X plus Y plus Z, X plus Y plus Z, put it in order, X plus Y plus Z. Again, these two, Y plus Z plus X, Y plus Z plus X, put it in order, X plus Y plus Z. Again, Z plus X plus Y. So, put it in order, X plus Y plus Z. Okay. Now, see here, X plus Y plus Z, X plus Y plus Z, X plus. So, you can take X plus Y plus Z common factor. So, here we can take X plus Y plus Z common factor, X plus Y plus Z common factor. What is left over? 1, 1, 1. Here, Z, X, Y, 1, 1, 1. Now, we can take X plus Y plus Z common factor. So, this is X plus Y plus Z. According to the property, if two rows, two columns are same, then the value of a determinant is 0. See, these two are equal, R1 and R3 are equal. So, therefore, this is equal to 0 because two rows are same. R1 and R3 are same. Two rows are same. Therefore, the value of determinant is 0. 0 into any number is 0. That is what we want to get, RHS. So, they can ask, prove that this is equal to 0 or find the value of x plus y, y plus z, z plus x, z, x, y, 1, 1, 1. Okay. So, if we simplify, the value of this determinant is found to be 0. That's it. Okay. Hope you followed this. Now, let us come to the next problem, same type problem. Now, prove that 1, 1, 1, A, B, C, B, C, C, A and A, B is equal to A minus B, B minus C and C minus A. This is very, very important type of problem. For 4 marks, you may expect this type of question for your 4 marks 2022 examination. Okay. Now, let us take LHS. What is LHS? 1, 1, 1, A, B, C, B, C, C, A and A, B. Now, this is R1, R2 and R3. So, the intention is just reduce this determinant so that by applying a property, at any stage, you can get the answer. So, the intention is to reduce this determinant to the simplest form so that we can apply the property to get the final answer. Now, here let me change. So, taking R2 dash and R3 dash. Let me take R2 dash. R2 dash is equal to R2 minus R1, R2 minus R1 and R3 dash is equal to R3 minus R2. Now, I will keep this R1 as it is, 1, A, B, C as it is. Now let us change this. 1 minus 1, 0, B minus A, or CA minus BC. Again, R3 minus R2, this minus this. 1 minus 1, 0, C minus B, and AB minus C. Listen to me. So, taking R1 is same, 1A, BC as it is. Taking R2 dash is equal to R2 minus R1, just this minus this. 1 minus 1, 0, B minus A, CA minus BC. Again, R3 dash is equal to R3 minus R2. 1 minus 1, 0, C minus B, AB minus CA. Now, if you observe carefully, you can remove the common factor here. This is equal to 1, 0, 0 as it is. This is also same. This is B minus A and C minus B. Here, BC as it is. You can take C common factor. Then what you will get? A minus B. You can take A common factor. This can be written as B minus C. Now, in this, we can take the common factor as A minus B and B minus C. B minus A is also equal to, see, B minus A can also be written as minus of A minus B. And similarly, this C minus B can also be written as minus of B minus C. Okay. Now, I will go to the next step. I will write there. Now, this is equal to first row, first column 1, 0, 0. 1, 0, 0. In the second column, what we have? So, B minus A and C minus A. B minus A can also be written as minus of A minus B. B minus A is also equal to minus of A minus B. And C minus B is also equal to minus of B minus C. So, here A, B minus A is minus of A minus B. And C minus B is also equal to minus of B minus C, and this is same, BC into C into A minus B, then A into B minus C. Now, this is equal to, I can take A minus B and B minus C out from these 1, 0, 0. This is A into A minus B is gone, minus 1, B minus C is gone, minus 1. This is BC. A minus B is taken out, what is left over is C, and B minus C is also taken, what is left over is A. Now, convert this matrix in such a way that all the elements below the principal diagonal are 0. See, these two elements are 0, convert this minus 1 as 0 so that you can apply the property and you will get the answer. Now, to convert this minus 1 as 0, we are going to use taking R3 dash is equal to R3 minus R2 again. See, this is A minus B, B minus C as it is, 1 A, B, C same, again 0 minus 1 C as it is, 0 minus 0, 0, this is minus 1, minus of minus 1, minus 1 plus 1, this is equal to 0, and A minus C you will get. Now, see here, all the elements below the principal diagonal are 0. So, all the elements below the principal diagonal are 0. Therefore, the value of a determinant is 1 into minus 1 into A minus C. Simplify this. I will write here. So, this is equal to A minus B into B minus C into 1 into minus 1 into A minus C. So, this is equal to A minus B, B minus C minus of A minus C. So, minus of A minus C can also be written as minus A plus C, that is equal to C minus A. This is A minus B, B minus C into C. Therefore, the required answer is A minus B, B minus C into C minus A, which is the required answer, that is the required RHS. That's it. See, convert this to a determinant so that all the elements below the principal diagonal are zeros. Then simplify. So, 1 into minus 1 into A minus C. A minus C can also be written as minus of A minus C. Minus A, minus into minus plus, that becomes C minus A minus B, B minus C and C minus A, which is the required answer. That's it. Okay. Hope you followed. Very easy and very important. Now, let us come to the next problem. Now, Prove that B plus C, A, B, C plus A, B, C, A plus B is equal to 4 times A, B, C. This is also a very, very important problem indeed for 4 marks. Now, let us take LHS. What is LHS? B plus C, B, C, A, C plus A, C, A, B and A plus B. Now, let us convert this to the simplest form. We can taking R1 dash is equal to R1 minus R2 minus R3. Just subtract the elements, that's it. Okay, so see, this can be written as, that's equal to, so R1 dash we are changing, these are same B, C plus A and B as it is, and the third C, C and A plus B as it is. Now we are changing R1 minus R2 minus R3. So B plus C minus B minus C. Again A minus C minus A minus C. This minus this. Again A minus B minus A minus B. See here, subtract all these. B plus C minus B minus C. A, C minus A minus C. A minus B minus A minus B. Cancel the terms which gets cancelled. So this is equal to, see here, minus B plus C minus C gets cancelled. This is 0 and B and C as it is. Here, check what are the elements which gets cancelled. Only minus A and plus A gets cancelled. Minus C is minus 2C. Everything will not get cancelled. C plus A and C. Now here, what are the values which gets cancelled? So minus A plus A gets cancelled, whereas minus B remains the same, minus 2B and B, A plus B. So we have converted into the simplest form. Now let us apply the property and simplify. That's it. Okay. This is equal to plus, minus and plus. So 0 into any number is gone. Minus into plus it is minus into minus plus 2C into this row and column is deleted. Then B into A plus B. B into A plus B minus C into B. Next, plus into minus minus 2B into this row and column is deleted. B into C is BC minus C into C A plus B. Okay. 0, this is gone because 0 into number is 0. Minus into minus plus 2C, this row and column is deleted. B into A plus B minus CB, plus into minus minus 2B. This row and column is deleted. BC minus C into A plus C plus A. Now I will go to the next page. That is equal to 2C into B into A plus B minus BC, again minus 2B into B into C minus C into A plus B, C into C plus A. Simplify this. So if I simplify this, what is the answer we want to get is 4AC, 4ABC. Let me check this. 2C into, simplify this, A into B is AB plus B square minus BC minus 2B into, simplify this, BC minus C square minus CA. Now this is equal to, multiply by 2C, 2ABC plus 2B square C minus 2BC square. Here this is minus 2, B into B is B square C, minus into minus plus 2BC square, minus into minus plus 2ABC. Now cancel the terms which gets cancels. So plus 2B square C minus 2B square C gets cancelled. Again 2BC square plus and minus 2BC square gets cancelled. What is left over? 2ABC plus 2ABC. This is equal to 4 times ABC. So therefore, the required answer is 4ABC. That's RHS. That is the required answer. See, what is the answer? 4ABC. 4ABC. That is the required answer. Okay. Now let us come to the next problem. So this is very easiest problem. Now what is to prove that x, y, z, a, b, c, x plus a, y plus b, z plus c is equal to 0. So take LHS, x, y, z, a, b, c, x plus a, y plus b, z plus c. Now very simple. See here, if you add these two, x plus a, y plus b, z plus c, then x plus a, y plus b, z plus c, 2 rows and 2 columns will be equal, then you will get the answer. Now taking c1 dash is equal to c1 plus c2, that is add these two, x plus a, y plus b, z plus c. This is same, a, b, c. This one same, x plus a, y plus b, z plus c. Now you can take the common factor. So x here, no need to take common factor. If you observe carefully, here the two columns are same, x plus a, y plus b, z plus c, x plus a, y plus b, z plus c. Two columns are same. This is equal to 0 because two columns are same. Two columns are same, identical. So two columns are same, therefore the value of determinant is equal to 0. That's it. That is the proof. Okay. RHS. There is one more problem like this. Prove that this is also important. A, B, C, then B plus C, C plus A, and again A, B, C, B plus C, C plus A, and A plus B 1, 1, 1 is equal to 0. This is also a very important problem. So here just this can also be written as LHS. Write down the LHS. A, B, C, B plus C, C plus A plus B 1, 1, 1. Now you can add these two same type, taking C1 dash is equal to C1 plus C2. What you will get? A plus B plus C. Again B plus C plus A is nothing but A plus B plus C. C plus A plus B is A plus B plus C. And this is same, B plus C, C plus A, and A plus B. Here 1, 1, 1. Now here we have to take A plus B plus C common factor. This is out, A plus B plus C out. And what is left? 1, 1, 1. B plus C, C plus A, and A plus B. This is 1, 1, 1. So see here two columns are same. Here two columns are same. X plus A, y plus B, z plus c, x plus A, y plus B, z plus c, this is equal to 0. Here also we have taken A plus B plus C common factor. So therefore, this is equal to A plus B plus C into 0. This is equal to 0 RHS. Very important problem. Okay. So this is how we are going to solve the problems. Okay. Now, these are few problems based on the properties of determinants. Hope you followed. Practice this, practice. Definitely will get these type of questions for the examination 2020. So these are all very important problem for 2022 examination. So that's all regarding today's session. Let us meet with the different problems and properties of determinants in the next session. Thank you very much.